Alright, in this next thing here it's called partial fractions. In partial fractions, it's just a bit of an introduction this year, but next year it's going to be used for quite a number of different things. What we're going to do is have a look. So basically, what is it? What's partial fractions? Okay, so if you have something like 5/6, for example, and you want to break that down into a couple of different fractions. So 5/6, for example, can be 3/6 plus 2/6, which of course then comes down to a half plus a third. So that's kind of like the partial fractions. Now you'll notice here, through no coincidence, there's a relationship with that. So partial fractions is that sort of thing, but then looking at algebraic fractions rather than just normal fractions. Okay, so let's have a look. Okay, so there's a whole bunch of different things, different forms that the fraction can be in. So one of them is like this: 4x plus 5 over x minus 3. Now you'll notice with this one, the degree of what's on the bottom and the degree of what's on the top are the same. So whenever that's the case, you need to, or in fact the degree of the numerator is larger than the denominator, you have to divide it out. So for this particular one here, a few different ways you can do it, but this is the way I like to do it. So x goes into 4x 4 times, so 4x times 4 is 4x, minus 3 times 4 is minus 12, and we're subtracting all of that. So 4x take 4x, 5 take negative 12 is 17. Alright, so that's as far as we can go. So this one here, if we could go back and think to our, primary school days when we did long division, we'd say that, it goes into 4 times with a remainder of 17. Okay, but we can go one step further and think of, okay, well, what's that 17? What's that 17 out of? Okay, so it's 4 plus 17 out of x minus 3. Alright, so that's that particular one expressed as a partial fraction. We can't go any further with that particular type. Alright, so let's have a look at another one. So this time x plus 3 over x squared minus 3x minus 40 in partial fractions. Okay. So with that particular one, you'll notice that the denominator this time is not factorised. So we need to factorise this first of all. So factorise denominator. Okay, so got to factorise it. And if we factorise it, x plus 3 over x squared minus 3x minus 40 will be equal to x plus 3 over 2 brackets, 2 numbers that multiply to give us negative 40, and add to give us negative 3 minus 8 and 5, I believe. Alright, So now let's have a look. So that means that x plus 3 over x minus 8 x plus 5 is equivalent to, I haven't used an equal sign there, something over x to take 8 plus something over x plus 5. Now the reason I haven't used an equal sign, and it's a technical mathematical thing, is that we're not allowed to swap sides with this stuff. So whatever's on the left hand side is equivalent to what's on the right hand side. So we can't say that they're the same thing, well, even though we know they're the same thing, but we can't use an equal sign, because if we had an equal sign we could do transformations, and we could, you know, add, subtract, divide, multiply to move things from one side to the other. Now we're not allowed to do that in this case, because we're making these two things be the same. So we've got to find A and B that make those two things the same. So first bit of making them look the same is put them over the same denominator. So there it is. Now, of course, over here, the left-hand one, we have to multiply top and bottom there by x plus 5, so it's a times x plus 5. And the other one, this one here, we've got to multiply top and bottom by x take 8, so it's b, oops, let's change me to a black, b times x take 8. And so those two things are equivalent. Now, you'll notice here that our denominators are exactly the same. So if these two things are equivalent, i.e. the same, that means that our numerators have got to be the same. So what we know from that is that x plus 3, oops, let's do that, change it to break, x plus 3 has got to be equal to a times x plus 5 plus b times x take 8. Alright, okay, so now we've got to solve that. One of the simple ways of doing that is that, so if we let x equal minus 5, if we do that, that will then eliminate this bit and tell us that 2 is equal to b times minus 13. And so b equals negative 2 over 13. And I'll squeeze it over here. If we let x equal 8, that then eliminates that part. And 8 plus 3 is 11, equals a times 13. So a is 11 over 13. So if we go back to what we started with, x plus 3 over x squared minus 3x minus 40 is equivalent to a, which is 11 over 13, x minus 8, plus b, and b is negative, so negative 2 over 13 x plus 5. And there is our final answer. Okie dokie. Alright, so those of you who were following should have noticed that I made a mistake here. that one, because if x is minus 5, minus 5 plus 3 is minus 2, not plus 2. That makes that a plus, and that a plus there. So just try not to rush. Mistake like I have done. Okay, so the next type is if you have a repeated factor. So by a repeated factor we mean alright, so they've got your repeated factor. Here is our repeated factor. We'll notice that it's squared. So in this case, what we do is this. So we've got 2x minus 1 over x take 2, x plus 1 squared. And that's equivalent to, now, what we need to have here is we need to have all the factors. So in this case, there are 3 factors. One of them is x take 2. We know that. X plus 1 is another factor. The third factor is one that's not necessarily obvious to people, but x plus 1 squared is that third factor. Okay, and obviously that third, it's not obvious to people, but when you have a look and you have a look back here, what we've got on the left hand side there, you'll notice that it's already there. Okay, x minus 2 times x plus 1 all squared. It's already there. How do you get x plus 1 all squared? By multiplying x plus 1 by x plus 1. Alright, so if that's equivalent, then what we've got to do is we've got to make it look equivalent. How do we make it look equivalent? We make it look equivalent by common denominator. Okay, so the A, this particular one there, we have to multiply by we'll get rid of that one. We have to multiply top and bottom by x plus 1 squared. So we get a x plus 1 squared. The B, so this one here, we need x plus 1 squared, and we also need x minus 2, so B, x take 2, x plus 1. So that gives us a squared, and the C, this one on the end, all it needs to be multiplied is by the x minus 2. Alright, so there we go. Now if these two things are equivalent, the same as we said before, we've already got our denominators the same, so therefore our numerators must be the same. So now what we need to do is work with 2x take 1, and that's got to be equal to, for these two things to be the same, got to be that. Let's just make that a little bit neater. Alright, doesn't look any neater, but anyway, get the idea. Alright, so if we use the same process before, substituting x equals minus 1 in there and x equals 2 in there, and you can then find a few things. Now I'll let you do that yourselves. So if you do that, you find that A equals 1/3, you find that B is equal to negative 1/3, and you find that C will be 1. So this particular 1, then 2x take 1 over, take 1, take 2, take 1 over x take 2, x plus 1 squared is equivalent to a, which is 1/3 x take 2, plus b, which is minus 1/3 x plus 1, plus 1 over x plus 1 squared. Alright, so if you're not sure about the algebra doing all that sort of to do that, then give me a yell and we will work through that. Alright, now let's have a look at the next sort. Okay, so first of all we need to factorize the x cubed minus 8 and difference of perfect cubes there on that one. So 5x squared plus 9x plus 10 over x take 2. Now this is a pattern you should learn about in methods. And so x minus 2 there, and x squared plus 2x plus 4. Here's the other one. Now this time what you notice is that you have a factor that's not able to be reduced or factorised in itself. So what do we do about that? Well, what we do about that is that we say that that's equivalent to right, so what are the factors? X take 2 and the other one's x squared plus 2x plus 4. So there's just an A on there. Now what we need to do here is we need to have bx plus c on our numerator. Okay, reason for that being that there's got to be a squared up the top there, here. So see there's 5x squared there. So we've got to, when we multiply this out, because when we multiply there, because we now combine that of course, and so that's equivalent to a times x squared plus 2x plus 4 plus bx plus c times x take 2. Alright, and of course you're going to get your x squareds there, which of course combine to give you the 5. So x minus 2 x squared plus 2x plus 4. Alright, so now we have a look at we know our denominators are the same, so that means our numerators, oops, wrong one, this one here, this one here, our numerators, this numerator and this numerator, have got to be the same. Okay, so let me, alright, so our numerators 5x squared plus 9x plus 10 is equal to a x squared plus 2x plus 4 plus b times x plus c times x take 2. Alrighty, so then we've got, again, we can expand this and get some simultaneous equations and solve for A, B and C. And so if we solve for A, B and C, and I'll let you do that, you'll find that A equals 4, B equals 1 and C equals 3. So that means we have that 5x squared plus 9x plus 10 over x cubed take 8 is equal to 4 over x take 2 plus x plus 3 over x squared plus 2x plus 4. Alright, so there's that one. Alright, there's one more that we need to look at, and that is when our degree of our numerator is greater than the degree of the denominator. Okay, and so there's the case there, x squared plus 5x over x take 1. So whenever that's excuse me, whenever that's the case, we then divide it out. So x take 1 into x squared plus 5x take 2. So x times x gives us the x squared, so we've got x squared take x, subtracting that, 6x take 2, x times 6 gives us 6x take 12, subtracting that, we get 10. What am I talking about? It's not right, is it? It's minus 6. So when we take that, we get 4. Alright, so what have we got? We've got x plus 6 then, so x squared plus 5x take 2. On x take 1 is equal to x plus 6 and 4 over x take 1. Now that bit on the end there, that bit there, we don't actually need to do anything more with that because that's as low as it can go. Alright, so there's partial fractions. So a brand new technique. As I said, this year we're not going to use it huge amounts of times, but next year we'll be using it plenty. And next year, once we get on some of our calculus stuff, it's going to be essential that you be able to do that. You can also use it for graphing as well. Again, that's for next year. But the actual process of partial fractions, we get started on this year. So that's exercise 8B, problem set number 8, that you can make a start on there. Now, of course, there's also calculator methods to be able to do some of these things. So your expansion, functions in your calculator, and that you can use also.